what do you think is the biggest challenge in translating quantum level simulations into deployable industrial tools?
Well, the thing is that I would say the biggest challenge that we are facing is the size of the system which we can study at this level of theory. In my particular case, I was working in a very small molecule, methane, which is basically the smallest possible carbohydrate that you can have. And we were studying the breakage of a CH bond in that molecule. And even when you have a very, very small system, it can get very computationally difficult because there is a lot of parameters to take into account if you want to have this very high level of theory. And on the one hand, there is importance because if we can understand on such level how the energy is flowing through the system, how the energy is actually being used, then it can have a very important industrial application because this particular reaction is still the main route to produce hydrogen. And then if we could understand better how to control this process with much smaller input of energy and the much smaller cost of the process, we could actually have much bigger gain. But the problem is in order to understand this on such a high level of theory, we can work on a very small system because if we would want to increase the size of the system, if we would want to, let's say, if we have a metal as a catalyst, it also affects the process. But if you want to take into account also movement of these atoms, the system would grow exponentially and it wouldn't really be doable anymore. So there is always this balance in between how accurate answer we want and how big of a question we can ask to get that accuracy.